Hello everyone, this is Subin Matthew, and this is my midterm project for uh, Predict 454. I decided to take the Titanic dataset mainly because I wanted to spend more time learning how to implement the algorithms rather than have to study the data. Um, the datasets available to me were the test and the train. There were 1,309 rows, 800 and something was in the train dataset and about 419 on the test dataset. The data variables available were age, siblings or spouses aboard, number of siblings or spouses aboard, the P class or the passenger class being first, second, or third, the gender, the number of parent, child, or children aboard the Titanic, the ticket number, the fare, the cabin number, and the port of embarkation, either Cherbourg, Queenstown, or Southampton. Now, it was pretty obvious to me as I went through some exploratory data analysis that there were 263 age values missing from the combined data set. And I did combine train and test into one data frame. And I decided to use the mice algorithm to impute the age and as well as looking at the fare distribution. I can see most of the fare distribution leans onto the left side between 0 and 50. I didn't think that a mean would be appropriate, so I took the median to replace the fare, missing fare. I went on to plot a chart for the mice plot, mice plot for whatever we're missing, and I see that age and fare, of course, are missing 20% of age in this case, and this survived missing because of the combined test data as well, and I decided to conduct the mice algorithms based on the CART method, the classification and regression, a density plot of the age value that were imputed, and then plotted against the normal distribution of the original data. I realized that the imputed data fits very well with the original age distribution. And furthermore, I did one more comparison. I wanted to see how the bar chart showed it, one through the with the mice output and one with the original data set. Moving on to feature engineering, I wanted to see how each of the variables compared against the target or the label. In this case, I created bar charts for the passenger class, the sex, the siblings or spouse count, the parent-child relationships aboard, And the port of embarkation, looking at the data from the bar charts, they were plotted using ggplot2. We were able to identify that the amount, you must notice that the NAs available here are actually because of the test data within the combined data set. The third class has a higher chance of not surviving, 1 being survived and 0 being not survived. This goes with sex as well. The males have a higher chance of not surviving. The females have therefore having a better chance of surviving. Here we see that if you have fewer members of the family, or if you are single, if you do not have a parent or a child aboard, you have a better chance of survival. Now, if you look at the percentage of people who survived with who have a parent-child relationship aboard, that actually decreases. I mean, the more as we go from 0 to 1 to 2, the survivability increases. You can see 7.3% of the people who had one other parent or child relationship aboard did not survive, but you can see 9% here survived. Now, the same thing goes for people who had 2 such relationships aboard. 7.3 increased to 11.7 on survivability. And the opposite happened for people who were single. About 80% decreased to around 75% when you compare survivors against non-survivors, or with for people who are single. Now, therefore, I have to look more into this relationship, because that alone cannot, this univariate comparison alone cannot explain what's going on. But moving on to the port of embarkation, it is clear that the port of Southampton carried more non-survivors than survivors. And Cherbourg, people from Cherbourg had a better chance of survival. If you look at the sibling spouse relationships aboard chart on survivability, if you had no siblings or no spouses, again, just like we saw in the parent-child relationships, the survivability decreased. Certainly, family should decrease the survivability. But I guess it has more to do with the involvement of gender as well in this. I will look at that later. I tried a box plot for the multivariate, but I didn't think that this was very important. So although I have it on paper here, I'm going to wait until I get to the next chart to begin explaining the multivariate relationships. Now this is a multivariate comparison between age, the port of embarkation, and the passenger class, separated into the male and female genders. You can see that this is the first class, this is the second class, and this is the third class. I can see Sherberg has, as well as this is a chart that I created in SAP Lumira, and I decided to compare, well, I did my multivariate comparison this way. I added the passenger count to the y-axis and the passenger ID to the y-axis. Of course, the chart would show me the count of passengers on the x-axis for each of these labels. I have the 3 passenger classes with their genders and port of embarkation. And you can see, as I suspected, most of the Southampton non-survivors are male. That's why, and most males traveled by themselves. So therefore, the number of family members that we saw earlier here that showed that their survivability increased as the number of family members increased, well, that is because of this. The males, a lot of males died in from Southampton, and most of them were single. As the women who were usually accompanied by children survived, the numbers skewed. And here we see that most of the survivors are not maybe from Southampton, most of the survivors are female. Of the third class. However, if you were to examine the first class passengers, you can see the female-male ratio does stand. Females always survived more than males did, but the amount of males that survived are different. The ratio of survivability among the males. I also did some experiments with splines and realized that the best model could be one with several knots in it without sacrificing for the degrees of freedom penalties. I use this information both well, mainly in age to create my new features. Created age old for people who are older than 70, for age child for passengers who are less than 17, whether there was a family involved, whether the child was of an upper class, whether an upper class passenger was a woman, whether the passenger was a male, and of course all 3 of the embarkation ports. I also calculated the family size based on the number of siblings or spouses accompanying along with the parent-child relationships aboard. And I added 1 for the passenger in consideration. I did some comparisons on the effect of each of these variables on survivability by creating a table for the proportions of survivors among these variables. And what I found was that the proportion of older people who did not survive was 85%. So I knew that was significant. Looking through the other variables that I created, the features that I created, the one other one that the rich child survived had a better chance of survival than non-rich child. We can see a rich woman survived better, 96.8%. And nothing else is as significant as the ones that I just mentioned.